Okay, so in this video we're going to talk about standard form, and we want to be able to get to the point where we can graph from standard form, or go from standard form to graphs to standard forms to graph. And this is actually what standard form looks like, and this should be a little bit new this year. Look, we've talked about slope-intercept form, y equals mx plus b. We've also talked about point-slope form, which is that y minus y1 equals m times x minus x1. Those are all formulas that we've learned because they're helpful in one point or another. Now, for instance, for slope-intercept form, it's really easy if you have a y-intercept and a slope. For point-slope form, it's really easy if you have a point and a slope as opposed to just a y-intercept. Standard form has its uses as well. And that's actually has to do with what the video we just talked about, which is actually the x-intercepts. It's also really nice to find y-intercepts. I'll show you that. And it's also pretty easy to find slopes, all from standard form. Now, it looks a little bit more complex than, say, slope-intercept form or point-slope form because, well, let's just face it, this is a little new, and so this is going to be a little bit complicated at first, but it should be easy after some practice. Again, but it has its uses, and it's going to make us actually, really, on our next units to come, when we talk about systems of equations, it's going to be really helpful. So, again, each formula that we have is going to have its own use, and it's going to be helpful in one situation or another. So again, that's what we're looking at. Standard form is what we're talking about today in this video. So make sure you have this down. AX plus BY equals C. All right. So I would have you guys try this out. There is an example here. It says 2x plus 3y equals 12. Can you graph that? Now, a while back, all we said is to solve for y, get it into y equals mx plus b form, slope-intercept form, graph your y-intercept, and then graph your slope from there. So go ahead and try that really quick. All right, so let's take a look at that. Let's solve for y. It means I need to get rid of my coefficient and my constant. We always get rid of the constant first, so let's go a little quicker here. Subtract the constant from both sides. Bring down the 3y equals negative 2x plus 12. I like to put the variable first. So negative 2x is going to come first. That's a negative 2x and a positive 12 there. And then I'm going to divide everything by 3 to get rid of the coefficient. That's going to leave us with y equals negative 2 divided by 3 is negative 2/3 x, and then 12 divided by 3 is 4. So this is the equation that you should try graphing if you haven't already. All right, so let's do that. We have a y-intercept at 4. So 1, 2, 3, 4. That's at the point 0, 4, because it's a y-intercept. And then we have a negative slope, so positive, negative. My line should be a negative slope. And the rise is a negative 2. And the run is a 3. 1, 2, 3. Down 2, over 3. Rise negative 2, run positive 3. And if I should go through all the way through the graph because I want a nice, good-looking line. If I decide to rise 2, that means I should run a negative 3. Rise 2, run a negative 3. Rise 2, run a negative 3. That should give us a nice little line for our graph. Okay? And now the next questions here. What is the ordered pair of the y-intercept? Well, we actually just talked about that because slope-intercept form gets us that really quick, right? That should be, again, y-intercepts always have a y value where x is 0. But I know what the y value is. That's at 4. So 0, 4 is the y-intercept. That's this point right here. And then the x-intercept, what is the ordered pair for the x-intercept? Well, that will be where it crosses the x-axis. Again, one more time, that means that x has a value, y is 0. So let's go figure out what that x value is. 1, 2, 3, 4, 5, positive 6. So this should be at positive 6, 0. And that's exactly where that's at right there. So 6, 0. That's my x-intercept. All right. And what is unique about these intercepts? Again, one more time, the rule is always that when you're looking for a y-intercept, it will have a y value and x will be 0. And when you're looking for an x-intercept, it will have an x value and y will be 0. All right, so this is the same equation that we were just working with the y-intercept given right here. I'm going to use this information to actually kind of start proving a point to you why standard form is really nice. So I have my equation again, just right from the last slide, is 2x plus 3y equals 12. I know that the y-intercept, the x is always equal to 0. Always. Because I have a y value and x is always 0. Well, watch what happens. I actually don't need a graph anymore to find the x and y-intercepts of an equation. Because all I need to do, because I know the y-intercept has x always equal to 0, I know that I can just replace the x with 0. So let's substitute that out really quick. I'm going to substitute out the x and replace it with 0. Well, 2 times 0 is 0. I just bring down the 3y equals 12. If I keep on solving for y here and divide both sides by 3, you get y equals 12 divided by 3, which is 4. We just found our y-intercept by plugging in 0 for x. Now here's the great thing about standard form. If I kind of look at this as a literal equation, and I still replace x with 0, so substitute out the 0, I substitute out the x and replace it with 0. A times 0, anything times 0 is just 0, and so that really just cancels itself out there. We're left here with by equals c. And again, we're looking for the y-intercept, right? So we're solving for y. If we divide both sides by b here to get rid of that coefficient, we're left with y equals c over b. And over here we got 4, but that was the y-intercept, wasn't it? So if I take the formula, ax plus by equals c, and I divide c by b, I should get the y-intercept, right? Well, let's see. Again, our formula was ax plus by equals c. This is the equation I had before, so 2x plus 3y equals 12. That would mean that a is 2, b is 3, and c is 12. If I took c divided by b here, well, c is 12, so y-intercept should be, again, c over b. So that would really be c is 12, so that would be 12 over, and b is 3. What's 12 divided by 3?
Oh, 4!
That's going to be 4, just like we got right here. But in this case, I didn't have to substitute out in 0 for x. I could just say, hey, the y-intercept is always going to be c divided by b. c divided by the number, or the coefficient on y. So the y-intercept will always be c divided by b. Always. Make sure you write this part down. It's going to be important. Is that going to be the same thing for the x-intercept? Well, the other one said y equals c divided by b. So this one has to say x equals. Remember, the x-intercept has always had an x value, and the y value is 0. So if I substitute out y for 0, we should be able to solve for my x-intercept. So 2x plus 3 times 0 equals 12. 3 times 0 is just 0, so that's just going to kind of go away. We're left with 2x equals 12. If we keep on solving for x, we divide by 2 to get rid of the coefficient. And we're left with x equals 6. And that was the same x-intercept we got earlier. So that helped me get my x-intercept. Let's look at the formula without any numbers put into it. This ax plus by equals c. With this time, we're substituting out y for 0, so the y is going to go. So ax plus b times 0 equals c. B times 0 is a 0, so that's going to cancel out. I got ax equals c. Again, I'm looking for the x, so I'm going to get rid of this coefficient by dividing by a. A's cancel out to 1, and I'm left with x equals c divided by, not b, but a this time. So this is going to be the formula to solve for the x-intercept. Let's check and see if it works. So I had 2x plus 3y equals 12. This was a. A is equal to 2. B was equal to 3, and C is equal to 12. Just like on the last slide, A is 2, B is 3, C is 12. So the x-intercept should be C divided by A. Well, C is 12, and A is 2. 12 divided by 2 is 6. Right? So there's our x-intercept. So there's something for our formula is if it is in standard form, the x-intercept will always be c divided by a. Write that down. It's going to be helpful for finding those x-intercepts later. All right. So I have a different equation here. I've changed it up just a little bit. Negative 2x plus 3y equals 9. I want you guys to pause the video and find the x and y intercepts and see if you can actually find the slope. We might use a graph here. You might still, or you can use those formulas that I gave you a second ago. So let's take a look at this one. We got negative 2x plus 3y equals 9. If I remember from my formulas, the y-intercept was c divided by b, and the x-intercept was c divided by a. Well, a is negative 2, b is 3, and c is equal to 9, so the y-intercept should be c divided by b, so 9 divided by 3. 9 divided by 3 is 3. My y-intercept is 3. And that would be the point 0, 3. Because the y is 3, x is 0. X-intercept would be c over a. Again, that would be 9, but over a this time, which is a negative 2. Now this is why finding x and y intercepts from the formula is going to be a lot nicer, because 9 divided by negative 2 is actually negative 4 1/2, or 0.5. Right? And if that were actually on the graph at negative 4, so 1, 2, 3, 4, it would be right here, and that would actually be kind of hard to spot on the graph, which is why having the formulas ready to go is going to be extremely helpful. That x-intercept will be at negative 4.5, 0. Because x-intercepts have x values and y is 0. And what is the slope? Well, if we were to graph that, we could probably find it. But we have standard form, and it should be actually pretty easy to find that slope. The slope-intercept form was y equals mx plus b. If somehow we could actually find what slope is, then we should be able to find our slope. This slope right here, but right now we don't have it in slope-intercept form, do we? That's what I'm going to recommend we do here. Let's solve for y and get this into slope-intercept form really quick. And get rid of the coefficient and the constant. So I'm going to lollipop. That's right. Get rid of my constant first. And that's going to leave me with 0 there. I'm going to bring down the 3y equals 2x. And that's a positive 9, so I'm going to say plus 9. And now I have to get rid of my coefficient. That means I need to divide everything by 3. And it gives me y equals 2 divided by 3 is just 2 over 3, or 2/3. X, and then 9 divided by 3 is 3. What's my slope? My slope is right there, the coefficient of x, so my slope is 2/3. Right? Now, let's go over here and do the same thing with a literal equation. If I said ax plus by equals c, and solve for y like we did in literal equations, I'd still have to get rid of the coefficient and the constant, all the same way. Get rid of your constant first, minus ax. So that cancels out to 0. Bring down by equals, and this is just c minus ax. Notice how I kept the x over here on the left-hand side, though, first. I'm going to do the same thing. I'm going to bring down the negative in front of the ax, and this is a positive c, so I'm going to say plus c. And then now I have to get rid of b, so I'm going to divide by the coefficient. Get rid of my b there. Y equals, well, negative ax divided by b would just be negative ax all over b. And then c divided by b is c over b. Now, you might actually notice something here. If this is in the form of y equals mx plus b, where b is the y-intercept, just a couple slides ago, we said that the y-intercept is c over b. It's kind of interesting. But also notice what's all in front of the x right here. This negative a over b. So that should be their slope, right? So to find the slope, we do negative a over b. Now let me show you what that means. Our original equation up here said negative 2x plus 3y equals 9. And this is in the form of ax plus by equals c, which it is. We should be able to find the slope simply from that. It says negative a, so let's take a look at what that means. If a equals negative 2, then the opposite a, so if I were to say negative a, what's negative a? Well, then you'd have to say that, what's the opposite of a? That would be the opposite of negative 2, which is a positive 2, right? And so if we're saying that A is a negative 2, we want the opposite of that, which is actually why we're saying opposite of A over B as opposed to negative A, because a lot of students get confused about negative A. So the opposite of A over B, if A is a negative 2, then opposite of A would be a positive 2. So I'm going to say 2 right here, or a negative 2, which would make it positive, over B, which is 3, then we get that the slope is 2/3, just like we found earlier. Instead of having to solve everything, I can say, well, the opposite of A, which is 2, over 3, which is 2/3. Right away. No problem there. All right, so this is what we've learned so far. In the formula, ax plus by equals c, we know that the slope is the opposite of A over B, the y-intercept is c over B, and the x-intercept is c over A. Make sure you have that written down and try this one out. All right, what's the x-intercept? Well, we know that x-intercept is c divided by A. What's c? That's 24. What's A? Negative 8. 24 divided by negative 8 is negative 3. There's my x-intercept. It's at negative 3, so that would be at the point negative 3 comma 0. The y-intercept is c over B. What's c? 24. What's B? 6. 24 divided by 6 is 4. So what's y-intercept at? It's at 0 comma 4. What's the slope? Well, that's always the opposite of A over B. What's the opposite of A? Well, A is negative 8. The opposite of negative 8 is 8. And B is 6. This can reduce. 8 over 6 reduces to 4 over 3. There's my slope. 4 over 3. Rise 4, run 3, positive slope. And we're done. Go ahead and try those problems below.